Hi there, it's Albert Luck again from luckymaths.co.uk, working on proportion 7 today, which is basically about best value problems. And we've got two kind of real life problems here, one involving bottles, which deal is the best value, and again, which potatoes are better value for money. So it's purely dealing with the ratio table template, again, which I feel set up to show the idea behind we're either going to work out the cost of 1, 2, 4, 8 or 12 bottles. But firstly what I'll do is, if shop A, let's say, is selling one bottle for 32p, shop B is 4 bottles for 112, now I'm going to turn that into pence, so that'll just be 112, and shop C, 12 bottles cost 360. What we can quite easily do, hopefully, so let's say with shop A and bottle, the one bottle from shop A, if it's 32 per bottle, that means 2 bottles would cost 64. And 4 bottles, therefore, would cost 128 or 128. And that already means shop A is more expensive than shop B, based on that alone. Now, of course, I could half, I suppose, 112 to show you that would be 56. Half 56 is 28p a bottle. Now, I've got the 360, as I said, at the end here for 12 bottles, but I haven't put 6 in, which is half of 12. But we could bring the 12 down to 4. Okay, so if we divide that by 3, okay, so that's how 12 becomes 4, we divide by 3. So 360 divided by 3 is actually 120. So if you split those 12 bottles, 360, into 3 groups, let's say, of 4 bottles, each group of 4 bottles costing £1.20, which is more expensive than shop B. So I have answered the question in that context, but what I'm going to do is I'm going to complete all the other blanks now to show you that it's always going to be obviously shop B that works out the best. If we double the 4 bottles, we turn them into 8, 24, 240. And what I could do, I suppose, is I could add together the 4 and the 8 now to get 12 bottles, just to show you we could work upwards and do that. So for this one, that's going to be 336, and this one is going to be 384. So again, no matter, and again, you don't have to do all this work, sorry. You just need to compare what I call like for like quantities. So the unitary method, finding the cost of 1, is going to work for you. But sometimes it might be easier, especially if you've not got a calculator, to maybe work up the other way. And maybe we could have gone to 12 with all of the bottles instead. But shop B is best. Now we've got, I've chosen a different problem, again involving different kilograms here, and deliberately made this one a little bit tougher because of this 3.5 kg for, let's say, shop C. So we get, let's call it, pack A 160, 1.2, pack B 252 for 1.8 kilograms, and then it's 480 for 3.5 here. Now I've chosen this deliberately because it's very difficult to make 3.5 easily the same as any of the other multiples that we've got, you see, of 1.2, because double 1.2 would normally be 2.4. And then I suppose if we triple 1.2, we get 3.6, which is, again, close to 3.5, but of course they're not exact. So firstly, what we could do is break the first pack down, and that is halving and halving again. Pack B is a little more difficult because I'm going from 1.8. I really want to get to 0.6, but that is okay if I divide by 3, and that just so happens to be 84. Half of 84 is 42. So again, already it looks like pack A, you see, is better than pack B because it's cheaper for those amounts we've got. If I double the 84, just to fill in this one as well to show you, that'd be 168. Right, let's go to fill in 1.8 now from the top, and I can add the 1.2 and the 0.6 together. 160 plus 80 means that would be 240. If I double these amounts now, because that's what I'm doing to get 1.8 to 3.6, 252 is going to become 504. So 480 and then 504. Now again, it's still difficult to see the comparison here between 3.6 and 3.5 kilograms. So this is why I've looked at a slightly different solution, let's say. 3.5, if divided by 5, we'll get to 0.7. If we divide 480 by 5, we'll get 96. And then I'm going to times that by 3 to get 2.1 kilograms. And I say that because I'm just going to box a couple of values that I've done earlier. If I add together the ones I've boxed from earlier, 1.8 and 0.3 kilograms gives me 2.1. So firstly, I'll fill in pack C here. 96 times 3 is going to be 288, or £2.88. If I add a 240 and the 40, that means 2.1 kilograms from pack A would be £2.80. And 252 plus 42 is 294, which means pack A is the better value, as it is cheaper for the same amount, okay, in all 3 bags. And just to be clear again, if we look at what I've been doing, all of the skills on this page involve timesing by 2, dividing by 2. There's a dividing by 3 as well, but I think that's the only difference here. The rest of it is really either double or halving. So again, a good use of the ratio table to do, these are more complex questions now, worth normally at least 3 marks in the GCSE Foundation exam. Thanks for watching.